Hello data scientists, welcome to Skillgate. In this course, we'll cover a business relevant sentiment analysis project end to end. Before we get started, a little bit about us. Skillgate envisions to provide you hands-on experience of industry-ready projects having real-life complexity. Every project we bring to you solves a real business problem end to end through a data science approach. Along the way, we will share DIY kits with you, having a dummy business case, a problem dataset, Python code, and additional business analysis tools for you to solve these problems yourself. If you are a student, you may create academic projects through us, or if you are a working professional, you may contextualize our courses further to solve your business problems. Needless to say, you may always reach out to us for any help you may need to achieve your objectives by commenting below or through our contact details provided in the description part below. Alright, let's get started. This is Skillgate's problem solving framework. We'll go step by step through this framework to understand, solutionize, and deliver on our project in hand. First thing first, let's understand a sentiment analysis problem from a business standpoint. One of the great entrepreneurs of our time, Bill Gates, has said that unhappy customers are the greatest source of learning for any business to improve itself. Well, the good news is, with the power of internet, businesses today get a huge number of customer feedbacks through their business website, social media page, business listing, etc. But the bad news is, majority of businesses do not even know how to use this information to improve themselves. Even the ones who do know primarily focus on structured customer feedback, like a review on a Google, Amazon, etc. Structured feedbacks have a rating along with the written review, which makes it easy to understand if a feedback is positive or negative, as is the case here. These are reviews of a restaurant we picked from Google. Here clearly we may see that ratings are a good proxy for review sentiment. And aggregated ratings also signify the overall sentiment for this restaurant, which is seemingly positive. However, unstructured feedback is where the volume lies. Over 1 billion people worldwide use Facebook, Instagram, and 500 million use Twitter. A sizable number of people share their product and service experiences directly on these platforms. The problem is, these feedbacks are unstructured. These customer reviews on Domino's are picked from Twitter. As you may see here, one has to manually go through each review to figure out customer sentiment. And definitely there is no aggregated sentiment that we may conclude from here. So the problem is, how do businesses analyze these unstructured customer feedbacks at scale? Well, this is where machine learning comes in. Natural language processing or NLP based sentiment analysis models can predict sentiments for such unstructured reviews at scale. This shall allow businesses to listen to almost all of their customers and serve them better. Alright, now when we understand the pain points behind picking a sentiment analysis project, now it's time for us to understand our dummy client ABC Restaurant's business case. Our client ABC Restaurant intends to build a binary review classification model for reviews received on their Facebook page. Binary here means positive and negative. So essentially, positive reviews are appreciations and negative reviews are criticism for our client's restaurant. Business intends to build an in-house customer support team to call back all customers who give negative feedback and try to resolve their issues or give them discounts so as to ensure the revisit. Client has shared historic data on customer reviews for their restaurant along with positive negative labels. Additionally, they have shared a fresh customer review dump with us to generate labels. So our deliverable to the client would be a sentiment-based binary review classification model and labeling on fresh reviews dump as positives, negatives. Let's understand our datasets further. Historical review dataset contains 900 reviews as text, along with liked as 1 meaning positive review and 0 meaning negative review, which our client got prepared through manual audit of these reviews. Also, we have a second dataset of 100 reviews from the current week, for which we have to populate this liked column through our sentiment analysis model. Let's understand how we would go about solving our client's business problem with a machine learning approach with this next section on solutioning intuition. First step towards building any machine learning model is data preparation. In the next set of slides, I'll explain you how we would clean and transform our data. Here I have taken 6 sample reviews from our historic dataset to discuss this data cleaning intuition part. Our objective with this data cleaning exercise is to drop unwanted non-value adding characters and words that would otherwise unnecessarily consume computational resources. Let's go step by step now to understand how we would achieve it. Firstly, as you may see, we have these dots and commas as special characters here, which strictly speaking do not tell us whether a review is good or bad. Even the numbers, as is the case in this fourth review here, is not telling us anything on the sentiment behind the statement. So let's drop these special character values. Alright, it's done. Next up, we would need to convert all words to small case because of this issue. As you may see, the two not here are the same English dictionary word depicting the same negative sentiment, but computer would understand them differently as a not with a small n and another not with a capital N. To tackle this, we simply convert all sentences to small case, like this. Moving on, as third step, we would do a couple of things. All words highlighted in red here are called stop words, which generally are non-value adding. These words mostly do not help us in understanding sentiment for a review, so we would drop these. Also, the highlighted green depicts how the same dictionary word recommend is used in different forms but has the same sentiment. To ensure computer understands these as the same word, we would convert all English words to their root. This process is called stemming. Alright, this is how a dataset would look post we drop stop words and stem the remaining words. As we may see now, we definitely have a reduced number of words in our historic reviews dataset. But a computer would still not understand this representation. For that, we need to somehow convert these words into numbers. For this, we have a fourth step here to convert this clean dataset to a bag of words representation through transformation. We'll discuss it next. Just to clarify, out of the 6 reviews we have discussed till now, I am picking up the first 3 for our discussion on bag of words intuition. So this is our dataset post cleaning. For transformation to bag of words representation, system would simply identify all unique words, also called as tokens, in the review column here, and form separate columns for each of these tokens like this. As you may observe, for every review, system puts a 1 if that token is present in the review or 0 if that token is not. Bag of words representation is called so as it discards information on order and sequencing of words. Also, when we come to the model building part, we would drop some of these tokens that rarely appear in our reviews. That way, we are improving sparsity. To know more on this, refer to the link attached in the description. Cool. This completes data preparation intuition part of our sentiment analysis model. Next up, we will discuss intuition on naive Bayes, which we would use as our model classifier. We would use naive Bayes classifier for our sentiment analysis model. Let me give you a quick intuition on how naive Bayes classifier works. Here I'm using the same bag of words representation we prepared in the previous section. Assume we get a new customer review saying this place is wow, and we have to predict sentiment for this review. As you know by now, post data cleaning, this review should look like this, having two tokens, place and wow. In bag of words representation, this new review would look like this with ones against the tokens wow and place and zeros against other modal dictionary tokens. By the way, all these tokens collectively are called modal dictionary. For classification, naive-Bayes classifier uses conditional probabilities. As we may observe in historic reviews for token wow, when it is present, review is always positive given the limited training data we have here. So it depicts a positive sentiment. Similarly, when token love is absent, review is always negative, depicting a negative sentiment. Likewise for place. For crust, however, review is both positive and negative when this token is absent. With 50-50 chances, we can't take a clear call here. Thus, we would need more data to decide whether crust as a token contributes to positive sentiment or negative. Likewise, we have done this exercise for all tokens, analyzing their conditional probabilities. With the limited information we have, we can see three tokens are showing positive sentiment against one that suggests negative. Thus, we are concluding this review is a positive review. This is exactly how naive-Bayes classifier would classify reviews for us. With this understanding, now we are all set to code. Let's get coding. Before we get started on the coding part, there are certain prerequisites you would need to know. First, we would use Google Colab for Python coding, which is Google's free cloud-based platform. We have already done a small video on getting started with Colab. Refer to the description part below for the video link. Okay, that was first. Second, you would need to create a new folder with the name to sentiment analysis in your Colab notebook folder, just like this, and copy all these model related files here. Link to these model files is also provided in the description part of this video. Over here, this 2.1 is our code file for building our sentiment analysis model. Let's open it to get started with our model building. Alright, we are on Colab now. Let's go section by section through this code file to understand what our code does. In this first section, we are importing a couple of standard Python libraries, NumPy and Pandas. Let me run this cell. Alright, it's done. In the second section, we are importing our dataset. For this, we first need to connect Colab to Google Drive. For that, click on this folder icon, then click on Drive, and then connect to Drive. Now we would import our historic reviews dataset from Google Drive in this next cell. Okay, our dataset is imported. Using this shape function, we may check the count of rows and columns we have in our data. Alright, so we have 900 rows and 2 columns in our dataset. Also, we may see the first few rows of our data with this head function. As you may see, we have review and liked columns here, with review column capturing customer feedbacks and liked capturing zeros for negative reviews and ones for positive. This next section is interesting, where we are doing data cleaning. We have already discussed the intuition on data cleaning in the last section. Here we would do the same using Python code. In this first cell, we are importing Python's RE, that is regular expression, and NLTK, natural language toolkit. Then we are downloading NLTK's stopwords file that has stopwords for 16 global languages. We are importing stopwords and Porter stammer from NLTK that we would use in the Excel. We are then filtering English language stopwords from our downloaded stopwords file and storing under this all stopwords variable. Let me run it. Alright, now we are all set to clean our data, which is 900 customer reviews. Let's get going. First up, we declare this corpus variable for storing customer reviews post data cleaning. We have this for loop here that runs row by row 900 times to clean every review that we have in our historic dump. With this first line of code, we are dropping all special characters and numbers. With this lower function, we are converting reviews to lowercase. With these next couple of lines, we are dropping all stopwords and stemming the leftovers. As last step, we are appending every cleaned review to corpus. Let me run it. Let's print this corpus and see how our cleaned reviews look like. These look familiar, right? Next up, we need to do data transformation to convert our cleaned dataset into bag of words representation. For this, we are using count vectorizer. This number 1420 here means that we are picking the top 1420 most frequent tokens and dropping the leftovers. This helps us to reduce sparsity and is a standard data science practice. By the way, this 1420 I reached to by doing some hit and trial. Let's run it. Moving on, we are storing bag of words representation of our reviews in X and historical labels in Y. Let's run it. Next up, we are saving this bag of words dictionary back to Google Drive. We would use this file for predicting sentiments of fresh customer reviews dataset, which our client ABC Restaurant has given us as a requirement. Then we are splitting our dataset into training and test using train test split from sklearn into 80% training and 20% test. Well, congratulations to you for making it to this point where we are all set to train our sentiment based review classification machine learning model. You ready? Let's do it. We are using naive Bayes classifier for model fitting to our training set. Let me run this cell. Great, our model is ready. We are exporting this classifier file back to Google Drive as well. We would use it for sentiment predictions on our fresh reviews dataset. This next section is on testing our model performance as to how well our model classifies good reviews as good and bad reviews as bad. Let's run it. Well, this is how our model has classified reviews from the test set into good and bad with accuracy score of 0.728, which means our model classifies 72.8% or 73% of reviews correctly, which is not bad at all. This completes model building part of our sentiment based review classifier for ABC Restaurant Limited. As you may see, both bag of words model dictionary file and naive Bayes classifier file have gotten created here. Next up, we have to predict sentiments for our fresh reviews dataset using this second code file we have here. Let's open it. Here we have to repeat the same steps till data cleaning on this fresh reviews dataset. For this, we are importing the same set of libraries. Then we are importing our fresh reviews dump. Alright, Next up, we are cleaning our fresh reviews. For data transformation, we are loading the bag of words dictionary we prepared previously and then transforming fresh reviews with this imported bag of words dictionary. In this next section, we are calling our classifier that we prepared previously and using it for predicting whys for fresh reviews. And finally, we are printing this file with predicted sentiments against fresh customer reviews. Great, coding part is now done. This is our modal output file on fresh reviews, which has modal predicted review sentiments. Let me show this to you. Over here, we have these predicted labels in the form of zeros and ones added by our sentiment analysis model. Zero means negative feedback, as is the case here with this first customer review. This definitely is a negative feedback. Similarly, 1 means positive feedback, as is the case with this next one, which seems like a positive review. With this, our job is more or less done, except for the last part, which is delivering this solution to our client ABC restaurant. For this, we need to prepare a client solution delivery presentation, something like this. Let me quickly take you through this delivery presentation as well. We had couple of deliverables. One, to train a sentiment-based review classification model, and two, to generate labels for fresh customer reviews. These were our assumptions. We dropped numbers and special characters from all reviews, and we assumed all reviews were in English language. Then we trained our sentiment analysis model to classify customer reviews as good or bad using naive Bayes classifier. So as our first deliverable, we have trained a sentiment-based review classifier that has 72.8% accuracy. As we have used Google's free computational resources, there is minimal operational cost to business with our approach. As our second deliverable, we have generated labels for fresh customer reviews that were shared with us, which looks something like this. A point to mention here, this last review highlighted in gray is a misclassification, as our model is only accurate 73% of the times and few misclassifications are bound to be there. From sentiment predictions obtained from our model on fresh customer reviews, it is evident that majority of ABC restaurants customers are not happy with the services on offer. This should definitely be a cause of concern for business. With further deep dive, we were able to gather this list of issues that ABC Restaurant's customer support team need to pick up as soon as possible to ensure customers revisit. Alright, with this, we have completed our course on sentiment analysis. Please share your queries and feedback in the comments section below. If you want to see more such machine learning videos, do like, share and subscribe to our channel. Thank you.